Okay, let's go over our identities and start our first day of simplifying and verifying trigonometric identities. Okay, so here's the reciprocal rules and the quotient rules, which you should be very familiar with. Let's review those Pythagorean identities one more time. The one that you must memorize is sine squared of x plus cosine squared of x equals 1. This one you must memorize. There's no way to make any of the other ones if you don't know at least one of them. Okay, now the other ones we can make, and I'm going to start to maybe do some stuff here in our mind. So let's take sine squared and divide him by sine squared. Oh, that's simply going to make a 1. What's cosine squared divided by sine squared? That would be cotangent squared of x. And what's 1 divided by sine squared? That would be cosecant squared of x. Okay, there's our second one. If we're ever doing a problem and need to substitute something in or out, we will use that one. And the third one, let's go back to our original, and I'm going to divide each and every term by cosine squared. So sine squared over cosine squared makes tangent squared of x. Cosine squared divided by cosine squared cancels out, makes a 1. 1 divided by cosine squared is secant squared. And so there is your third Pythagorean identity. So if you're ever solving a problem and you see tangent squared plus 1, you can replace it with secant squared. I am going to put a little note here because there's something special about all of these identities. Must be squared. So sometimes people ask me, if I see a sine plus a cosine, can I just replace that with a 1? And the answer is no, they must be squared. Down here, the even odds, I told you it would be a good idea to memorize the ones that have the negatives that cancel out, and those are the cosine ones. So cosine of negative x becomes positive x, as well as secant. And then the other ones I'm going to do in a boring black pen here because the negative pops out. The negative goes out in front. That's a negative cosecant and a negative tangent of x and a negative cotangent of x. The ones that disappear are the cosine and secant ones. Okay, now what are we doing? For the rest of this chapter, we are going to be simplifying trigonometric expressions or verifying identities. So that just means there's an equal sign or not. For example, okay, this one right here. They're going to start you off with some hints. So it says we're going to simplify this by rewriting each trig function in terms of sine and cosine. So this is a very popular technique where you replace all the fancy identities with just sines and cosines. Okay, so first you write down the problem. Okay, step 1, always write down the problem. And you must use equal signs. Let's put a note here. Use equal signs between your steps. Okay, that is not a suggestion. That is a requirement. This problem equals a different problem. I'm just going to be changing it around. So first, draw a very nice big divide bar. Okay, and we're going to replace cotangent of theta with something else. Cotangent is cosine theta over sine of theta. How about cosecant? I can replace him, but I have to write in terms of sines and cosines. That's 1 over sine of theta. Okay, so this entire chapter, they're like little puzzles. And the great thing about these puzzles is there's lots of ways to do them, lots of frustration, probably a lot of erasing and starting over again. That's how it works. Okay, nobody knows how to start them right away unless you have years of experience doing this, which I'll try to give you guys about a week and a half's worth. Now, can you cancel a denominator with a denominator? Absolutely. Okay, so what's left in the numerator then? Cosine of theta. And in the denominator, we just have a 1, so that means this equals cosine of theta. So this trig identity, which equaled this stuff, which equaled this stuff, equals this stuff. And so I'm going to box my final answer. You must put equal signs between each step. They're all equal, they're all equivalent, but they're getting more simple. Okay? In the beginning, we're going to try to give you some hints just to kind of give you some techniques, get you started. Okay, here's another technique. Okay, show that this equals this by multiplying the numerator and the denominator by something. Of course, what you do to the top, you do to the bottom. Okay, so I have to tell you a rule here. Here's the rule. Okay, you pick one side. You pick one side. Okay, you work on one side only. Okay, you only work on one side. You work on it, and you turn it into the other side. So you don't work on the left, work on the right. You pick one side. And what you do is you tell people what you're picking. Okay, for example, I am going to pick this left-hand side right here. So I'm going to say left-hand side. The left-hand side is cosine of theta divided by 1 plus sine of theta. And my job is to work on this, do stuff until it turns into that. So the great news is, there's the answer right there. You know what you have to turn it into. But you have to show all the steps that legally get you there. And the hint that they gave you was multiply top and bottom. Put parentheses around that quantity by 1 minus sine of theta. Okay, this is a very popular technique. You'll get familiar with it. Okay, but they're telling you that that's what you should do. So in the numerator, I am not going to distribute that. I'm just going to wait and see if I need to distribute that in later. Okay, sometimes you have to. Sometimes people multiply it in, then later they factor it out, and they put it back in. The place that we're going to work on right now, okay, is down here. This one has a plus, and this quantity has a minus. Who remembers what that's called? It starts with a C. O-N. Conjugates. Okay, conjugates. And what's so awesome about multiplying conjugates? They make a difference of squares. Okay? And what's so awesome about things that are squared? Well, I'll just give you a little peek here. Things that are squared are identities. Okay? So then you think identities. All right, that's what we're going to do. So let's go ahead and do some work. That's our goal right there. Firsts make 1. Outers and inners cancel. So when you have conjugates, all you have to worry about is the last. That's minus sine squared of theta. Okay? So conjugates make difference of squares, and now that you have something squared, we can go back to this previous page, except it's a little bit arranged. 1 minus sine squared. So if this was the 1, and I need to minus the sine squared over there to that side, if it was 1 minus sine squared, it would equal cosine squared. Okay, so the denominator, instead of that, let's take that out and replace it with cosine squared of theta. Now some people say, how do you know you're supposed to do that? Well, 2 terms simplifying to 1 is a great idea, but let's also peek at the answer. Your answer has to have a cosine. So do you think changing from sine squareds to cosine squareds is a good idea? In this case, it seems like it is. Okay, sometimes you try things that look like good ideas and it turns into a big pile of mess and you have to abort and start again. But I think this is a good idea. How about that answer for the numerator? 1 minus sine. I see that right there. It's a good thing we didn't distribute it in because I'm thinking we're going to have to factor it out because I want that. So let's write cosine of theta times the quantity 1 minus sine of theta. Okay, so keep your eye on the prize. You want that quantity, but down here you only want 1 cosine. So how are we going to make the denominator have only one cosine? Well, if we cancel the cosine from on top and a cosine from the bottom. Cosine squared means cosine times cosine, which means we are at the very end here. The numerator has 1 minus sine of theta, and the bottom has cosine of theta. And that's exactly what we wanted to make. We turned the left-hand side into the right-hand side. Okay, remember this rule here. You can only pick one side, and you work on that one side until you turn it into the other side. And that's how you show something equals something else. Okay. Example 3. Okay, let's do some work on this identity problem here. And the hint that they gave us is make a common denominator. So when you're adding or subtracting fractions, sometimes you have to make a common denominator. So let's go ahead and leave a lot of space there for my new common denominator. Cosine squared of theta divided by 1 plus sine of theta. Make sure your fraction bars are as long or short as they need to be. All that stuff needs to get down there. This minus sign's way over here. Try to work neatly. And so let's change 1 into 1 plus the sine of theta over 1 plus the sine of theta. Now they have a common denominator. Okay, make sure you use an equal sign. So let's put these fractions together with that one common denominator. And the numerator is 1 plus sine of theta minus cosine squared of theta. Okay, this does not seem very simple. So I'm thinking we're going to have to do some work on it. We're going to have to try some things. Can we cancel 1 plus sine, 1 plus sine? Well, absolutely not. This is an entire quantity. If we cancel those out, we'd kind of be getting back to here. I put those there for a reason. So those are not going to cancel out. So where are we going to work? If you are thinking something about the squared, okay, you're in the right area. I'm going to write down that identity. What's the identity with cosine squared again? It goes sine squared plus cosine squared equals 1. Okay, but this problem has 1 minus cosine squared. Here's 1 minus cosine squared. So let's see. If we have a 1 and I minus the cosine squared to that side, then this identity would say sine squared equals 1 minus cosine squared. So those two terms can come out and be replaced with sine squared. So let's go ahead and do that. Let's write sine squared of theta instead of those two. I have to write the rest of the problem. Of course, the entire problem has to get written every line. It cannot magically appear later. Your sentences won't be equal. Okay, so this is how you get full credit for working logically and showing lots of nice work. Now, I think we still need to do some more stuff. Can we cancel these signs? No. In fact, let's write a note here. No canceling that and that. In fact, let's put some parentheses around it because it's an entire quantity. Either you cancel the whole quantity or you leave it alone. So what can we do in the numerator? It's your favorite, guys. Factor out a sine. And that would give me sine of theta plus 1. Don't forget the 1, right? If you distribute it back in, that makes a sine. Divided by 1 plus sine of theta. And can you cancel an entire quantity? Absolutely. That equals that. And so my final answer, wow, is pretty simple, is sine of theta. Who knew that that problem was equivalent to sine of theta? So this chapter is like puzzles, and you never know really how you're going to do them. You have to try. Okay. Oh, establish the identity. Would you like to work on the left-hand side or the right-hand side? That's kind of a tricky question because, here's another little note, you always pick The more complicated side. What? The more complicated side. Absolutely. It's so much easier to simplify something than to complicate it just the right way. So let's take the left-hand side. So say left-hand side equals. And let's write down the left-hand side. Okay, and we're going to work on it until it turns into secant. Okay, we need to come up with an idea here. Nothing is squared, so let's not think about those Pythagorean identities. But maybe I could think of another way to write cosecant. Cosecant is 1 over sine of theta. And maybe I can write tangent another way. So this is the technique where you're writing everything in terms of sines and cosines. If everything is sine and cosine, then you see stuff that either goes together or cancels out. So now we have a 1 left on top, cosine of theta on the bottom, and what does that equal? Perfect! We did it! Secant of theta. So that technique is changing everything to sines and cosines. Okay, number 5. Definitely pick the left-hand side. Left-hand side. This says sine squared. So I'm going to write this out for you guys. Sine of negative theta times sine of negative theta. I'm going to write 2 sines. Plus, I'm going to write 2 cosines. Cosine of negative theta times cosine of negative theta. Okay. When you have a negative and a sign, what happens to it? The negative sign is going to pop out in front. And this negative sign is going to pop out in front. And a negative times a negative makes a positive. Sine squared of theta. We have 2 sines. Here, cosine, the negative cancels out, disappears. And so we have a cosine of theta times a cosine of theta, which is cosine squared of theta. What's sine squared of something plus cosine squared of something? 1. We did it. And for this last one here, we are going to simplify it by factoring. Okay, now there's no left side, right side, so we're just going to start by writing down the problem. And it gave you a hint. So one of the things you have to think about doing is looking for things to factor. Let's make sure we use an equal sign. So in the numerator, I see sine squared minus 1. This is a difference of squares. So that's going to factor into 2 nice quantities. Do you know what they are? Sine of v minus 1 times the sine of v plus 1. Okay, and in the denominator, we're going to factor by, let's just factor out tangent of v. Tangent of v times the quantity sine of v minus 1. So this is one of those instances where you have quantities. I can even put parentheses around tangent if that helps. Since these are all being multiplied, I can cancel one quantity with the entire quantity, which leaves us sine of v plus 1 divided by tangent of v. So that is one technique, factoring. We're going to practice all these techniques and then stop giving you hints so you get better at it all by yourself. Great.